Welcome to Honors Geometry, Lesson 2.5, Justifying Steps of Equations. Alright, what's going on here? We're getting ready to show geometric proofs. In order to do that, we'll do some algebraic proofs because you're a little bit more familiar with solving equations, and that will help us get ready for proofs and proving that theorems are true. Theorem is a statement that's proved true. Remember, we had a postulate where a statement is accepted as true without proof. Well, theorems, we're going to prove that they are true. So let's go ahead and move along and talk about solving an equation. Alrighty here. We've got this beautiful equation. I'd like you to solve it. So what's the first thing you would do? Oh yeah, you would definitely use the distributive property and multiply that 5 to both terms on the inside. 5x plus 25 equals 2x plus 31. Okay, we have x's on both sides. Take care of those two x's by subtracting 2x from both sides. 3x plus 25 equals 31. Subtract 25 from both sides. 3x equals 6 when you subtract 25 from both sides. Divide both sides by 3. X equals 2. Now what we're going to do is wait for each one of these steps. We're going to give a reason, a why. And I know you're probably going to get sick of hearing that question, but I'll be asking that question quite a bit. So let's go ahead and learn as to what the why answers are. Here are most of the properties that we will use with solving equations. There are a couple more, and we'll talk about those in a few minutes. The addition property of equality, that's a mouthful. When we write it down, so we don't have to write it down so much, we'll just write add prop eq. I know it's EQ, but that sounds good to me. Subtraction of property of equality, you can write subt prop eq. Multiplication property of equality, you can write mult prop eq. And division property of equality, you can write div prop eq. Okay, what are these properties of equality? When you add something to both sides, check. Subtraction of property of equality, when you subtract the same thing from both sides. Multiplication property of equality, you multiply both sides by the same number. And division property of equality, divide both sides of the equation by the same number. Distributive property, I just showed you that, where you take a number or a letter on the outside of a set of parentheses and multiply that x times each term inside the parentheses. Thereby distributing, passing that out to each one of the terms on the inside. Substitution, that's where you replace equals with equals. And then CLT, combine like terms, or simplify. I'll let you write out either one of those. It doesn't matter to me. It really doesn't matter, whichever one you prefer. Alright, so let's get at it. Let's solve an equation and justify each step. Oh yeah, a major beginning step. Let's go ahead and move on. Okay, x over 3 minus 5 equals 31. Why is that true? You ask, and I shall tell you, because it was given to you. I just told you that it was. Alright, so what's the first thing you're going to do to both sides? You're going to add 5. and you're going to get x over 3 equals 36. What allowed you to do that? The subtraction property of equality. And we're going to put the results of the subtraction property of equality and using that with the results of doing that. Okay? Multiply both sides by 3. X equals 108. What allows us to multiply both sides by 3? The multiplication property of equality. And that's how you justify the steps in solving an equation. Let's look at another example. 28 equals 2x plus 6 times the expression x minus 5. Why is that true, you ask? No, I'm asking, not you. Because it's given. It's given that that's true. Okay, go ahead and distribute that 6. 2x plus 6x minus 30. What allows us to do that? The distributive property. Alright, we have x's on the same side here. 28 equals 8x minus 30. That would be combined like terms. Okay, next step in solving this equation, you would add 30 to both sides. 58 equals 8x. What allows us to add to both sides? The addition property of equality. And yes, you do want to organize this so that they're on the same line this way. The adding part you don't need to, but line up the results of that adding with the addition property of equality. I want it to be organized. Please be organized. Divide both sides by 8. Looks like it's 7 1/4, or as your calculator probably puts it, 7.25. And what allows us to divide both sides by the same number? It would be the division property of equality. And that's how you justify each step in solving an equation. Now let's look at a few other properties. Alright, we're going to learn 3 properties other than algebraic properties that we can use in solving equations and for using in proofs. They're going to be R, S, and T. The first one is the reflexive property. It says that any number equals itself. You know, A equals A. You can almost kind of look at that and say reflective, but don't ever write it or say it. Just kind of in your brain, like spin it through. It's the reflexive property. Any number equals itself. The next property is the symmetric property. If one number equals a number, then that number equals a number. Wow, was that very confusing. It's just saying that you can switch sides. And you know you've done this all the time. Last year in algebra, you know, you would write, you'd solve an equation and you'd get 10 equals x. But nobody in their right mind, other than possibly Mr. Manning, would say 10 equals x for the answer. You would all say x equals 10. All you've done is switch sides with the number and the variable. And that's what's going on with the symmetric property. And a great way to remember that is the symmetric property is the one that starts with an S. And what you're doing is you switch sides. So that is a symmetric property. If A equals B, then B equals A. And then the last property is the transitive property. See, I told you it was R, S, and T. Okay, the transitive property, wait a minute, before we go on, where have you heard the word trans before? Maybe you've heard of transatlantic, or like a transcontinental railroad. Okay, trans means to go across. So, the transitive property, if A equals B, and then B equals C, you're going to go across. That's why it's called transitive property. Then A is going to equal C. That's the transitive property. Now let me show you a couple of geometric examples. Ready? Length AB equals length AB, or the measure of angle A equals the measure of angle A. That would be an example of, boy, that doesn't write so well. Let me write with this better. This should work a little bit better. That's an example of the reflexive property. If the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A. Okay? That is where A and the measure of A and the measure of B have switched sides. This is an example of the symmetric, wow, I can't spell tonight, whatever day it is. That is an example of the symmetric property. Yeah, I'm going to show you. The next one is going to be an example of the transitive property, of course. And it could be, you know, measures of angles or segment lengths, either one. If AB is equal to CD and CD equals EF, then AB equals EF. You've gone across and you set things equal to each other. All right, let's show just a couple more examples so that you have this down so that you can come in tomorrow and do some homework in class. Okay? Addition property of equality. If RS equals TU, then RS plus 20, well, what'd you add to the left side? 20. You better add 20 to the right side. TU plus 20. Multiplication property of equality. If the measure of angle 1 equals the measure of angle measure of angle 2, then 3 times the measure of angle 1. Okay, on the left side it was measure of angle 1, now it's 3 times the measure of angle 1. What'd you do? You multiplied that left side times 3. You better multiply the right side times 3. 3 times the measure of angle 2. Substitution. If A equals 20 and A plus 5B equals 75, then what? Well, we can substitute equals for equals. So where this A is, I'm going to write a 20. So 20 plus 5B equals 75. And that will help us move along to solving that equation. Reflexive property. If x is a real number, then x equals, well, duh, x. Reflexive property, anything equals itself. Symmetric property. If AB equals CD, then CD equals, that's right, you guessed it, AB. And then the transitive property. If the measure of angle E equals the measure of angle F, and the measure of angle F equals the measure of angle G, then the measure of angle E equals, that's right, the measure of angle G. And with this will conclude the notes on Honors Geometry 2.5, justifying steps in equations.